Let me log in.
So EKS is nothing but COPS, KOPS, or are they different?
It is different. Okay. So this is the EKS service, Elastic Kubernetes service, and Amazon EKS, fully managed Kubernetes control plane, right? So the benefit of using this EKS service is that you don't have to manage your own cluster, right? You don't have to create your own master. So as I said, like master contains few components. Master contains the etcd, master contains the API server, master contains the control manager, and so these are the things which master contains, right? So like if you are going to manage your own clusters, in that case, sometimes it really become a painful thing to manage your own cluster, right? So if you have a small infrastructure where you are running only like few of the containers, maybe 200, maybe 400, maybe 500, so in that case, EKS can be a good choice if you are trying to run the services only on the AWS, right? If you have a plan to run some of your workload on different environment like Azure, maybe some of the workload on your Google Cloud, maybe Alibaba, maybe DigitalOcean. So in that case, creating your own cluster is the best choice. What I believe, because like you will not. Then in that case, you don't have to go and worry about like how the things are working in case of PCS and how the things are working in case of Azure Kubernetes service and how the things are working in this GKE, Google Kubernetes engine, right? So when I say that these are the services provided by different cloud provider, and they say that you don't have to manage your own cluster. You don't have to manage your own cluster. The cluster is going to be managed by your cloud provider. So that is what we mean by these EKS, AKS, and GKE. Okay, so I hope you got the answer for your question. If I talk about the COPS, so COPS is one of the tool, and it is also one of the open source tool available, which allow you to manage your own cluster, right? Which allow you to create your own cluster. So COPS is an open source community maintained tooling for production grade Kubernetes cluster installation and management, and we can always go and read about it from this. Okay. So you can always go and open this link and find out like what all things can be done by using COPS. But yes, as of now, we are going to explore the other tool, that is KubeADM. Right? KubeADM is one of the most popular tools available, and it is one of the graduated tools available. So where do we have this? Okay. Okay, so this KubeADM is also is a tool built to provide best practice of fast path for creating Kubernetes cluster. It performs the action necessary to get a minimum viable secure cluster up and running in a user-friendly way, right? So if you really wanted to contribute in this application, so in that case, you should know a bit about this about this Golang, application. And if I scroll down, so we can go and open this page also. So you can see, like, this project have 2,000 stars, and how many contributors? 64 contributors, right? Okay, so this is the tool, and yeah, the purpose. KubeADM is a tool built to provide best practices. So just, by using this KubeADM, you can go and create a cluster. Now, like, by using KubeADM, what you can do, like, you can go and run this KubeADM init command to bootstrap the initial Kubernetes control plane node, and then you have this KubeADM join command to bootstrap a Kubernetes worker node. And when I say worker node, that means I'm talking about the stable logic. Okay. Now you can also go and upgrade the Kubernetes to the different version. So that is do upgrade command to upgrade a Kubernetes cluster to a newer version, and then do reset command. Okay. So now what we are going to do, we are going to create our own cluster, right? So now you got the answer that by using this KubeADM and the kops, and you can go and create your own cluster. But if you are interested to manage, if you are not interested to manage your own cluster, then you can also go for like managed services, right? So let me launch 2 of the instances, launch instance, and then we have this community AMI, and then we have this, we can go and use Ubuntu provided by this canonical, right? We are going to use the 16.04, and T2.micro, not T2.micro, we are going to use medium, T2.medium, and then configure. Okay. Kubernetes master. And as of now, I'm going to create like, one security group, and I'm going to open all the port numbers, right? So let's open all port number, but this is not the recommended process in case of production environment. In production, you need to make sure that you always open these specific port numbers, which is required. So let's choose our key pair and click on this launch instances. So it says that the Kubernetes master security group is already available. Now I can go and choose the existing one, Kubernetes master, where it is. Now Kubernetes master always required, at least 2 GB of RAM. So you need to make sure that you have like 2 GB of RAM available in your system, and it is good to have 2 virtual CPUs. So that's why I have chosen this T2.micro or T2.medium instance type, right? And we have like a couple of more instances like T3A.small also is available, which is cheaper than this T2.medium instance type. So you can always go and use this T3A.small instance type. And I'm going to change this thing because we're going to run this thing at least for an hour. So why not save some cost, right? So till that time, I can go and create one more instance for us. So go and click on this launch new instances and configure instance. And here we are going to change instance type. So T2.micro is totally fine. and the rest of the things is going to be same, like the instance, on the AMI and the storage and everything is going to be same. And we are going to change the security group. That's it. So change the security group. Do we have worker? Yeah, we have worker. Okay. I'm going to create a new worker. Open all traffic and review and launch. So I'm just stopping this instance because I wanted to change the instance type, from T2.medium to something else, which is more cheaper. And nowadays we have a new calculator available from AWS. So okay, I think the instance has been stopped. Now I can go and change the instance type from here. Change instance type to this T3a.small. Yeah. Again, the reason is not simple. Just to remind you, the reason is very simple. Just to save some cost, right? And this T3a.small is a Nitro type instance available in AWS, which has been launched recently by AWS. So uh, it has some new features basically. Okay. And let's change the name of this. So we are going to oops. Okay, we got the public IP address. Great. Fine. So now we are going to open the Git bash in our system, and so we are going to move to the folder download. SSH-i Docker, and then we are using Ubuntu operating system, so the default username will be Ubuntu. Okay. Now let me open this, Chrome, and let me show you that we can always go and read some of the information from the Kubernetes official page, and then a Kubernetes installation using Kubernetes. This Kubernetes.io is the official page provided by Kubernetes, and we have a detailed instructions that what all things should be there, and what all things we can go and follow in order to install this Kubernetes cluster. So you can see here that the operating system should be Ubuntu 16.04 plus, and Debian 9 and CentOS 7. So if you are planning to run this Kubernetes, so I think it is not going to support this RHEL 6, right? And Fedora 25 plus. Okay. So here is the information which is really important. Now, these are the instructions which you have to do in case of Ubuntu. If you are trying to run the cluster on CentOS, so you can always go and follow these instructions. But as of now, because we are running everything on Ubuntu. So we are going to install a couple of the packages on our machine. So let's clear our screen and paste the command here. So it is going to install like two packages, the curl and the apt transport https. And after this, we need to install, first of all, we need to import the key. So we are going to import a key of which is available on this URL. Clear this screen and run this command. Right. So the key has been imported. It is showing you okay, and that's totally great. Now what we need to do, we need to update the repository. We need to update the repository. So by using this command, what we are trying to do, like we are trying to create a file. We are trying to create a file in this directory, source.list.d. So this is one of the directory available. And over there, we are trying to create a file kubernetes.list, kubernetes.list. And the content of this file is going to be, dev and this URL. Okay. So this is what we are doing here. And now what we can do, we can go and copy the whole stuff and it is going to create a file. So you can create the file by using editor, but when you have like fewer lines, so sometimes I try to refer this way also. Okay, if you wanted to add something else, you can always write, like I wanted to add some more lines like this. But as of now, I think we have only the requirement to add, this line. So I'm going to say like AOF and then hit enter. If I try to show you the content, in that case, etc apt, and then we have this sources.list.d and then kubernetes.list. Right. So this is the content which got available to us by using this cat command, and now we can always go and run this apt then update just to update the repository. Right. As of now, the repository is not updated. Sorry. apt-get then update. Okay, so you can see here it should be visible. Yeah. So you can see here that the repository got updated for us, and now it is showing us this one. So this information came because like we have added we have added one repository, right? In case of Red Hat, in case of CentOS, it is we try to create a file called yum.repos. In a folder that is yum.repos.d. So, but in case of Ubuntu, it is this folder. Instead of yum.repos.d, we have this sources.list.d. Okay. Now what else? So we can go back and now we can go and copy this command, and we need to install this kubelet, kubeadm, and kubectl on every machine. We need to install kubelet, we need to install kubeadm and kubectl on every machine, right? Whether it is a master, whether it is a worker. Run this thing and so the latest version of this kubelet and kubectl and kubeadm has been installed. It is 1.18.3 minus 00, right? So this is how you can go and install this version. And if in your production you are using some other version, so I think you need to find out the right version, and then you can say like something 1.14, maybe like 1-00, something like this. So you can go and check the version, and then you can go and define the version to install this specific version like this. Right? But as of now, we have already installed the latest version. That is totally fine. So if you are trying to set up the new environment for your company, so I will recommend you to use the the latest version, because the latest version have some new features available. Okay. Now what else? This command is not really required. It is when you're trying to run the things in your production environment, then you can go and run this command just to hold the upgradation, so that if anybody try to run the command without acknowledgement and without knowing, so in that case they will be getting the error. So we always need to unhold the things before we try to upgrade these packages, right? So this is one of the good thing available. Now, one of the most important thing which we haven't done so far is the installation of Docker, right? So before we start the services and before we actually start playing around it, we need to make sure that Docker should be available on our machine, isn't it? Yes. Now, apt get installed docker.io. Say yes, and then hit enter. Okay, so the same process we have to go and follow on our worker node. So we are going to follow the same process. So why don't we take the history from this server? I think that will be more easier for us. So I'm going to create a file. So let's say like vi and Kubernetes.sh and so here like we are missing something, this line. So we will say HTTP and it is dev. Yeah. Okay, so the first command is to install like one package, which is fine. And here is not really required in our script. We are trying to create one script, right? And sudo is also not required because we are going to run this thing from the root user. And we are going to import the key, then we are going to create one file. Okay, and then this command is also not required here. Not this one, yeah. Okay, fine. So these many things, and if I show you the this one, so it is also trying to restart the service of Kubernetes, right? So it is also trying to restart the service of Kubernetes. Okay, so we are going to do that, right? We are going to do that. So let's go and copy this thing, go back and paste it here. Fine. So I think now we are done with this. We can go and save it and restart our service. So before we go and run everything on our worker node, so we are going to keep this file on our GitHub repository so that you guys can also go and have a look to this whenever required. So let me go and make a clone of my GitHub repository, git clone https github.com and then slash the owner name and then the repository name, not git. So the repository has been cloned successfully. And before I copy this file kubernetes.sh, I would like to say Kubernetes prerequisites. Now copy this thing, Kubernetes prerequisites, to the folder called history with this, which we just downloaded. Then we should be having Kubernetes folder. Okay. And inside this Kubernetes, we can copy. Now we can go inside this history folder, and if we try to run it, let me clear the screen first of all. So git status. You can see, like, we added one file here. Now we can say git add and dot every file available in my current folder, and then we can say git status git commit -n and added prerequisites and say like this. So you can see, like, one file changed and 12 insertions. Now we can push this thing. We push origin and then master. I'm trying to push all the changes to my master branch. It is asking for the username and the password. Fine. So we have done everything, on our Kubernetes master. We are going to treat this machine as my master. And I can also go and change the host name, but not really required as of now. Now I'm going to follow the same process on my worker node. For that, I created one script, and then we will be initializing our master. Right. So let's go to our Chrome and try to copy the public IP address or the private IP address of the worker node. Okay. So docker.pem, and then we have this to user update the public IP address. Say yes. Right. Sudo su. So the IP address is 106. Remember. And now what we can do, we can say git clone, and then again the same URL, github.com/the owner, then / the name of the repository. .git. Okay. So now what we can do here, now we should be having a file of folder history. So the history folder is available. We have this Kubernetes folder available, right? That's great. Now we have this Kubernetes prerequisites. So I can go and execute this Kubernetes prerequisites file, and everything which we followed so far manually, all those things is going to be happen automatically. I think we are missing one thing, that is, like, we haven't defined that we wanted to stall. Okay, I think we haven't defined one thing, like -y option at one place. That is what we need to update, I guess. Oh no, I think we did it already. Yeah, yeah. We need to add like -y option, so that is fine. Okay, everything ran successfully, and we can also go and verify this stuff, right? And we can say like whether the Docker version, Docker version has been installed and everything is installed so far. And we can also go and verify whether the service is running or not. Status, yeah, see, the service is also running. This is our worker node. That's really great. So now we can go back to our master, and we are going to bootstrap our cluster, right? We are going to bootstrap our cluster. So the command is very simple. We are going to run, by using kubeadm. So kubeadm and then init command. Yes. So let me execute the command for you. Kubeadm and then init command and hyphen API server advertise address equal to the IP.
If we use EKS, do we need to follow whole this process?
Now, if you use EKS, then you don't have to install the cluster by using kubeadm. In that case, you just need to add this worker node into your cluster, right? So that is what you need to do. You need to join the worker node into the cluster.
Okay.
As I said, we are using AKS where if we are not interested to manage our master node our own, because when we manage our master node, then we need to make sure that the master is going to be available all the time. It should not be down, so we should be running at least 2 or 3 we should be running at least 3 master nodes, and you can think of the running 3 master nodes can be a huge amount of cost, and also that you have to go and do everything your own, whether it is like upgradation, whether it is like maintaining the high availability. So everything is going to be managed by you. Right? So that's why some of the people in some of the organizations are not using their own cluster. Their own cluster. What they are doing, like they are using the managed services by the AWS, like EKS. So this step is not really required. This step, kubeadm init command is just to initialize or bootstrap your master. I hope you got the answer for your question. Now kubeadm init command, and then you need to define this hyphen API server advertise, and then address is equal to the IP address of the master. So 172.31.43.72 is the IP address of the master. You need to say pod network CIDR is equal to 192.168.0.0/16. So this is going to be pod network address. And why I'm using this range? Because I'm going to use a network plugin which is Calico, and Calico recommend to use this pod network, right? 192.168.0.0/16. Now say this hyphen and then ignore And okay, we don't need to add this option, that's fine. Fine, now we can go and run and this command, so hit enter, and it is going to initialize everything for us, right? So it is, first of all, it is pulling the image. So pulling image for required for setting up Kubernetes cluster. So one thing I would like to highlight, that whenever you're trying to run, whenever you're trying to upgrade the cluster your own, so in that case, before you upgrade the cluster, always try to pull the image, right, at your system. So you can always pull the image by using this command, qadm config images pull. See, so very handy, very successful, and now finally we are getting this message: cube or control plane has initialized successfully. So we are done. Now it is saying us that you should now deploy a port network to the cluster. So this is what we need to do, and we need to follow a couple of other instructions also. So, and it is also saying that to start using your cluster, you need to run the following command as a regular user. So if you wanted to run the Kubernetes cluster as a regular user, so in that case, you need to follow these instructions. Okay, then you need to deploy this pod network. So as of now, we can go and check like how many namespaces are available. So kubectl get namespaces is the command which allow you to check the available namespaces in your system. And finally, we are getting this error. So as I said earlier, that whenever you try to interact with the master, so you are going to interact with the API server. You are going to interact with the API server, isn't it? So in order to interact with the API server, so first of all, we have to go and configure this thing. And whenever you get this message, the connection to the server localhost 8080 was refused, so you can always follow the same instruction. Copy this command, paste it here, hit enter, and copy the next command. Here, and okay. So we executed like 3 commands, and now we can run the same command namespaces, and you can see like we have 4 namespaces available in our system. 4 namespaces, right? So cube system is the namespace which contain every resource required by the by the Kubernetes cluster. So if I try to show you that how many pods we are running, and when I talk about the pods, so pods are the basic unit of your cluster, which in which we run all the containers, right? So pod is one of the basic unit of your Kubernetes cluster. Okay, in pods you will be running your container. Okay, so if you have any application which is containerized, so you can go and run that application inside a pod. Okay, kubectl and then get pod. And if you wanted to list the resources in your namespace, that is kube system, so you can always go and define by using -now. Hit enter, and you can see like it is showing us these things. So these things are running, but as of now, this core DNS and this etcd core DNS is not running. It is showing us 0 by 0. So the reason is like the pod network is not defined yet, right? The pod network is not defined yet. So we need to make sure that the pod network is deployed. Pod network is deployed on your machine. Okay, so let's go and follow this instruction, right? And we can always go and copy this link and paste this link in our browser. Scroll down, scroll down. Okay. So you can read about it, like, we have like couple of networking and network policies is there. So whenever we install the network plugin, so different kind of network securities get deployed in our cluster. So now we can go and use the Calico as of now. So see, the Calico is an open source networking and network security solution for containers, right? Open source networking and network solution, security solution for containers. And this is what we are going to use. So we can say like install or this Calico, and then we can go and click on this Kubernetes, and then we can say like quick start. See, so we have all these instructions, and so we already bootstrap our master, right? And we have also executed these commands on our root user. Now we need to install this Calico. We need to install this Calico network plugin. So copy this thing and then paste this thing in your terminal. Okay. So it is going to, apply one great thing about this Kubernetes, which I really like, that you don't have to go download the file in order to apply that. You can always, define the complete absolute path and say kubectl apply and then -f, and it is going to deploy all the changes, right? It is going to deploy all the changes. Hit enter. It's going to read this YAML file and will be deploying the changes. So you can see, like, so many things got created for us. So there are like a lot of custom resource definitions. Once you will be having advanced knowledge about the community, so you will always you always come to know about this custom resource definition. So as of now, this config map and the cluster role is also deployed, RBAC authentication, and the cluster role binding. So whenever you create the cluster role, so you always create the cluster role binding also, right? And cluster role again, and the cluster role binding for different one. Okay. Now, if we try to run the same command, kubectl get pod -n, and in the namespace that is kube systems. So you will see that this Calico thing has been deployed, the Calico kube controller, and the core DNS is also running fine. So these things are the basic things which is always required in your cluster, right? These are the basic things. And setting up a cluster is one of the difficult tasks, which we always do in our production environment. So you should know about it, that how we can go and create our own cluster. Okay. Fine. So now what else? And now we need to say kubectl get nodes, right? So as of now, we can see that we have this master 43.72, right? And it is showing as a status ready. Role is master, age is 7 minutes 11 seconds, and the version is v1.18.3. We can scroll up, and now we can join our worker node to this cluster. So as of now, the worker node is not joined yet. So when we were trying to bootstrap the master, so we got this. So you always need to keep this thing safe with you. You always need to keep this thing safe with you. So copy this thing and then run this command on your worker node, and then you should be able to install. Not install, basically you should be able to join the worker node or the slave node within the cluster. So go to our worker, and here we can go and try to execute this command. Now our worker node has been joined successfully, and it is saying us that writing kube let environment file with a flag to file this location. So this is the flag available, a file where we have the flag. And it is saying us that kubectl get node on control plane to see this node join the cluster. And so we can go and run this command again, which we already executed, and we will see that worker node has been. So Now go and run the same command kubectl, and you can see that the worker node has been added to the cluster, and it is saying that the status is ready. The status is ready. 36 seconds ago. Now we are ready to deploy our application on this Kubernetes cluster, right? So, and you need to make sure that you always log into your master, and then only you run the command kubectl, right? Whenever you run the command kubectl, so it is going to interact with your you know with your API server. So API, you have seen, if you try to look at this command which I executed on my master, so you can see, like, we have this IP address, that is the IP address of the master, and the port number 6443. So the API server can be accessible on this port number 6443, 6443, and this is the token which got generated for to join this worker into the cluster. Okay, so 6443 is the port number. You need to make sure that whenever you wanted to join the worker to the master, so the port number 6443 is always open between them. Okay. So let's deploy one application. So we are going to deploy one Nginx container on our Kubernetes. So there are like a couple of ways we can go and do and perform this activity, but we are going to do this thing by using command line. kubectl is the command which is going to interact with our API server, and API server will be sending the instructions to the worker node. So kubectl, then create deployment, and then we can define the name of the deployment, Nginx, right? kubectl create deployment Nginx, and yeah. So even if you go and run this command, so it will work fine. No, it will work fine, but I'm going to add a couple of more options. So I'm going to say, like, target port. Okay, let me check the CLI. kubectl create deployment. Oops. So this is not available in this page, so I will just go and open this sheet. kubectl create deployment. Okay, so you always need to define this. First of all, kubectl create deployment, and then you need to define the name of the image. So as of now, we are saying that the deployment name is going to be Nginx, right? And we are saying that the image which we are going to use is deployment Nginx, right? So this is what we have. Image Nginx. So if I try to show you this image Nginx, so it is available on our GitHub, right? So go back, and we also have something called target. Yeah. So this option is very useful. The target port, whenever we have the requirement to hit the container or a specific port number, then we will go and define the target port is going to be 8000 or 80. But in our case, it is going to be 80 because Nginx Nginx runs by default on port number 80, right? And we are going to say hyphen port is equal to maybe 8080. So hyphen port is equal to 8080, or you can say 8081, anything which you would like to say, right? So it is totally up to you. So here what you are saying that whenever you say like port is equal to 8080, so basically you are saying that you will be accessing this application, you will be accessing this deployment or the container or the application on this specific port number. So port is equal to 8081, and then you can always say like target and then port is equal to 80. So here you are saying that the target which you are going to hit is going to, you are going to hit the target on port number 80. So we are going to create a deployment. We are going to create a deployment. That is the name of the deployment is Nginx, and then we are saying that the image is Nginx, right? So you are going to create the deployment by using this Nginx image. So if Nginx is running on port number 80, then you need to say that target port is equal to 80, so that whenever anybody requests, the container, so in that case the request gets forwarded on port number 80, right? So that is what we are saying here. The target hyphen port is equal to 80, then hyphen, and we can define one more thing here, that is the type, right? So that is the type. We have different type of deployments available, and I'm going to show you that what all things are available. But as of now, you remember about this node port. This node port says that whenever you are trying to create a deployment, and then it will go and create a container, and it will go and create a container which has this image running Nginx, and we are saying that the type is like node port. That means if anybody try to access the by using this worker node IP address, so in that case they can go and easily access the resources. That means your cluster is available. Your cluster can be accessible from outside of a cluster, basically. Sorry, the container is available outside of your cluster. The container is available outside of your cluster. That is what we are defining by using this type is equal to node port. We have other things also. If you wanted to make your service available inside the cluster, so in that case you can always say that you can always say the cluster IP, and if you want to create the load balancer in AWS by using Kubernetes, then you can say that type is equal to load balancer. So this option is not relevant here. This is basically when we try to create the service. So let me go and hit enter, and let's see like what happens. Okay, so this fine. So this is the command which we executed here: kubectl create deployment and then nginx, and the name of the nginx, right? So whenever we just simply run this command, so it is going to create the resources in your namespace that is default. In your namespace that is default. So now the point is like, what is default namespace, or what is namespace? So namespace in Kubernetes, if you wanted to have an isolated network, so in that case you always create the namespace, right? So you always create the namespace, kubectl get namespace. Now, so we have like 4 isolated network as of now. We have 4 isolated environment in Kubernetes cluster. So if we wanted to check that how many deployments we have in default namespace, so you can always mention -n. You can also mention --, namespace. See, it is showing you that you have 1 deployment, and whenever you create a deployment, so it also create the pods, right? Create the pod where your container will be running. So as I said earlier, the pod is one of the basic unit of your Kubernetes cluster. See, as of now, the pod is running, and inside this pod we have a container available. And it is saying that one by one, and running status is running and restart is 0. So now if I try to show you one more command, kubectl -get pod and -o option wide, it will show you that in which worker node this pod is running, in which worker node this pod is running. So you can see here this pod is running on this worker node 43.106. Okay. Now if I try to so this is how you create the containers in your community. So you have seen that we haven't done so many things, in case of Docker, like when we were running Docker and when we were running containers by using Docker. So we used to we have to go and do a lot of stuff, and scaling in that case is not really feasible, right? But by using Kubernetes, you can simply scale the resources very easily. And before I go ahead, I would like to cover some of